Hello programmers, welcome to Gilgeekify programming. I'm Said Konsol and I hope you have a wonderful time creating something amazing with your programming skills. This is a tutorial video about Chrome extension development with focusing on JavaScript and CSS injection. A Chrome extension is a small software program that can be added to the Google Chrome web browser to add new features or modify the browser's functionality. We are going to learn how to build a Chrome extension using Manifest version 3 from scratch. You will learn how to control the Chrome extension's behavior, how to set and change Chrome extension icons based on conditions, what the Chrome Storage API and Chrome Scripting API are, how to use them, and much more. My extension is compatible with all Chromium-based browsers. I've tested it on Google Chrome, Microsoft Edge, Brave, and Opera. I chose the name of this Chrome extension Injector Plus. We can call it an unlimited lightweight injection tool that supports injecting inline JavaScript code, external JavaScript files, internal CSS code, and external CSS files. JavaScript and CSS injection are powerful techniques in web development that enable developers to create interactive, dynamic, and visually appealing web applications. However, they should be used responsibly to avoid security and performance issues. For testing purposes, I will inject custom JavaScript and CSS code into multiple websites, including ChatGPT, YouTube, Facebook, Wikipedia, example.com, and more. This video marks the beginning of my complete project playlist. I would greatly appreciate your feedback on it. Feel free to download the final source code from my GitHub repository. I will also include the download link in the description. If you found this video helpful, please like it, subscribe to my channel, and turn on notifications. Thanks. In general, JavaScript injection serves two main purposes: legitimate and malicious use. Here is a table summarizing the distinctions between proper and malicious JavaScript injection. For more in-depth information, you can refer to my videos in the Chrome extension development tutorial playlist. At the beginning, let's check exactly what we are going to create. It's my Chrome extension, Injector Plus. And this is the extensions button. I've defined my extension button as a toggle, which operates in two states, enabled and disabled. I've set the initial state to enabled. When the extension is enabled, it automatically checks the URL of each tab loaded in the entire browser against specified websites and their associated custom scripts and then injects them. You are watching customized versions of websites that have been customized by my extension. Alright, let's start the project from scratch. In the first step, let me show you the project structure. This is the project structure I designed. I've provided you with the tasks for each file. Please review them carefully. Our next step is to code these files. I intend to provide a brief explanation about folders and files. We have three folders. Assets folder. This folder contains all of the extensions icons. Core folder. Here you'll find all the files related to the extension's behavior and logic. Inject-2 folder. This folder is where you can place all the custom scripts you want to inject. And we have 7 files, each of which has an explanation that you can read. The files: inject-to.js, functions.js, extension.js, and injection-process.js are executed in order within the background.js environment, using the import scripts function. To save time, I've already created the project structure for you. Now let's review it. This is the extensions icon in different conditions: default, enabled, and disabled. The core folder contains the main extension files. The inject-2 folder contains the custom scripts we want to inject. Alright, let's begin coding with manifest.json. In the Chrome extension environment, manifest.json is a configuration file that provides essential information about the extension. It's structured as a JSON object, containing key value pairs that define various properties and settings for the extension. This is the extension's name. This is the extension's description. This is the extension's manifest version. I use version 3. This is the extension's version, typically following semantic versioning. The permissions key is used to declare what the extension is allowed to access and interact within the browser. In this case, I only need scripting and storage permissions. The scripting permission enables the extension to dynamically inject and execute custom JavaScript code into web pages, commonly referred to as content scripts. The storage permission grants the extension the ability to access and store data on the user's local storage. This permission is essential for saving and retrieving settings, preferences, or any other data required for the extension's functionality. Host permissions enable extensions to interact with URLs based on matching patterns. When using the value all_URLs for this permission, it grants the extension access to all URLs, allowing it to interact with and inject content scripts into any website, irrespective of its domain or location. In a Chrome extension environment, the background key is used to specify the background script or service worker that operates in the background of the extension. In this case, I've added the script background.js. This background script is a JavaScript file responsible for running tasks in the background of your extension, such as event handling, state management, and background processes. By using the action key, you can use the Chrome Action API to control the toolbar button for your extension in Chrome's UI. I've set the title of my extension to toggle and assigned a default icon. I'm using the default icon for the enabled state because during the initial installation, I want my extension to be enabled. I've set the default icon in various sizes. The action key relates to the extensions button in the toolbar. And the last one, the icons key is used to specify icons representing your extension in various sizes and contexts, including the browser toolbar, extensions menu, and Chrome Web Store. Alright, now let's run the extension in Google Chrome. Simply navigate to Manage Extensions, enable Developer Mode, and then use Load Unpacked to select your extensions folder for loading. Sorry, there is a typo in the icon names. Excellent. As you can see, the extension loaded successfully. This is the extension button in the toolbar. When you hover your mouse over it, you'll see the default title I specified in the manifest.json. Let's define the functionality of background.js. I use the import scripts function to import my scripts in order. I want to import 4 scripts: inject-to.js, functions.js, extension.js, and injection-process.js. In the background.js environment, the import scripts function is used to import and load external JavaScript files into the background script. This enables you to include additional scripts and libraries, expanding your extension's capabilities for various tasks and functions. I can say that import scripts works similarly to PHP's include, but in different contexts, one in client side and one in server side. Okay, let me add some comments right here. Now let's code these scripts in order. I'm starting the coding with inject-to.js. For your convenience, I've added some comments in these files. Here I'm defining an array variable that contains the websites I want to inject my custom JavaScript and CSS into. All values should be in hostname format. Alright, let's code functions.js now. In this file, I define all the functions required for the entire extension. The first function I want to define is the update extension icon. By using chrome.storage, we can access and manage data in the user's local storage, including functions for getting, setting, removing, and clearing data. Right here, I've created a table outlining the differences between Chrome Storage Local and Chrome Storage Sync. You can choose one of them based on your needs. In this case, I will use local storage. Okay, let's return to the function. I'm retrieving the state from Chrome storage. Based on the current state, I define the conditions to update the extensions icon. I'm defining the paths of the icons as variables, using a single line if statement, or more precisely, a ternary operator. I specify the new icon path. Finally, I use chrome.action.setIcon to set a new icon. So the update extension icon function checks the current icon based on the state from Chrome storage and sets a new one between the enabled and disabled icons. This function controls the extensions icon on the browser toolbar. The second function I want to define is the change extension icon. This function is similar to the previous one, but with minor differences. It retrieves the state from Chrome storage and toggles the extension's state and icon. If the state is true, it changes the icon to enabled. If the state is false, it changes the icon to disabled. Excellent! Now we have two functions to handle extension icons in different conditions. The third function I want to define is the extension status report. This function is optional, and you can add it if you are interested. I'm defining it solely for debugging purposes. For better report output, I clear the console. I display the list of target websites we want to inject as a table. I display the total number of target websites. This is how we can display all the data stored inside Chrome storage. Finally, I display the extension state. Alright, we have all the necessary functions. Let's proceed to code extension.js and define where these functions should be called. Chrome.runtime.uninstalled is an event in the Chrome extension API that allows you to listen for when an extension is first installed, updated, or when Chrome is updated. This is how we can separate actions for first installs and update events. In the context of Chrome runtime uninstalled, the reason property indicates the reason why the event was triggered. It provides a string value that can have one of the following values. Install. This reason is used when the extension is first installed. Update. This reason is used to when the extension is updated or its version changes. Chrome_update. This reason is used when the Chrome browser itself is updated. Developers can check the reason property in the event listener's callback function to determine why the Chrome runtime uninstall event was triggered, and perform specific actions based on the reason for the event. Alright, I use Chrome storage to set my extension's state to true, because I want it to be enabled by default during the initial installation. Then I call the update extension icon function to keep the extension's icon up to date. Also with the update reason, I again call the update extension icon function to keep the extensions icon up to date. When I say up to date, I mean that the extensions icon changes based on its state. As for the extensions icon, a true state signifies an enabled icon, while a false state signifies a disabled icon. So these are the actions we perform for the first installation of the extension and for extension update events. Now let's perform actions for when Chrome starts. Chrome runtime on startup is an event in the Chrome extension API that allows you to listen for when the Chrome browser is launched or started. This event is triggered when Chrome starts or is restarted, and it provides an opportunity for extension developers to perform tasks or set up functionality when browser begins. As before, I simply call the update extension icon function to keep the extensions icon up to date. Now let's perform actions when the extension button is clicked by the user. Chrome action unclicked is an event in the Chrome extension API that allows you to listen for when the user clicks on the extensions button in the browser's toolbar. When this event occurs, it triggers a callback function, allowing you to perform specific actions or behavior in response to the user's interaction with the extension button. I call the function to update the extensions icon, and then I reload the currently active tab using chrome.tabs.reload. And I call the function globally once to ensure that my extensions icon is displayed correctly in all cases. Okay, let me demonstrate how these methods and functions work in Google Chrome. I'll show you all the actions in order. First, let's examine the initial installation of the extension. Nice. Now, let's look at the extension update event. In Chrome's Manage Extensions, the update button and the reload button are not the same thing. But in the Chrome runtime uninstall event, they are both referred to as update reasons. Very well. As you can see, the extension icon is correctly displayed up to this point, based on the state from Chrome storage. Let's check the event when Chrome starts, or better to say, when Chrome is launched or restarted. We can simply exit Chrome, then open it again. But for added convenience, I've created a restart button as a bookmark. To create a restart button for your Chromium-based browser, all you need to do is create a bookmark with Chrome Restart as its URL. Okay, so each time you open Chrome, the block of code inside Chrome runtime on startup runs. This code helps maintain the extension icon based on the last active state. Alright, now let's check the actions when the extension button is clicked by the user. When I click on the extension button, it should change the state and icon to their opposite state. It should also reload the currently active tab you are in. It seems there is an issue. I apologize for the mistake. I should be calling my extension icon changer function right here. Excellent. As you can see, all of the functions are working perfectly. Also, when you exit and open Chrome, it loads the state and icon from your last saved state in Chrome storage, as per the previous function. Let's examine the final event. I should call the extension icon updater globally right here to save the extension's state and icon when the extension is turned off and on manually by the user. Very nice. I've checked all the functions and methods I used for the extension's behavior in action. Now let's define injection-process.js and injection-types.js. First, let's define the injection types. In this file, I've implemented a feature that is not mandatory for use. You can utilize it based on your preference. I will define a global object called injector that provides 4 types of injection: injecting inline and external JavaScript, and injecting internal and external CSS. Let's define the functions. This is the function to inject inline JavaScript code. First, I create the script tag, and then I inject it before the closing HTML tag by using document element.appendChild. To define the function for injecting an external JavaScript file, I followed a similar process with some differences. Okay, let's define the inject internal CSS function. Right here again, first I create the style tag, and then I inject it before the closing HTML tag by using document element.appendChild. And for the last one, I will define a function for injecting external CSS files into the web page. Very well. In the injection-types.js file, we have an injector object that includes functions for injecting JavaScript and CSS. Alright, let's get to the exciting part of the extension, defining the injection process. In this file, I will define the main logic of the extension. I should define the process of dynamically injecting content scripts into websites. By utilizing the Chrome tabs unupdated method, we can add a listener for updates to tab throughout the entire browser. This method takes three parameters: tab ID, change info, and tab. Tab ID is the ID of the updated tab. Change info is an object containing information about the tab changes. It typically includes properties like status and URL. But in this case, we only need to use status. Tab is an object that represents the updated tab itself. It holds various properties related to the tab, such as tab.url for the URL and tab.title for the title. This code checks if the status of a tab has changed to complete. In other words, it captures when a web page has loaded completely. Now I'm checking the extension's state. I want to perform the injection process only when the extension is enabled. Or to put it more precisely, when the state is true. I will check if tab URL is defined and not null to prevent error output. I'm defining a for each loop to iterate through each website in the inject-to array that I previously defined inside the inject-to.js file. Then I check if tab URL includes the current website based on the hostname format. Now by using Chrome scripting execute script, I want to execute scripts in the specified tab and all its frames. Chrome scripting execute script is a method in Chrome extensions that allows you to inject and execute JavaScript code into a web page from your extension. This enables you to modify and interact with the content and functionality of web pages programmatically. You can use the execute script method based on your interests or needs. In this step, there is an important point that I must mention: execution world. By using the main world, I define the content script to run alongside the page's main JavaScript. The default value of the world is isolated. Here are the differences between main and isolated in a Chrome extension environment. In this case, I need to use the main world. If you want a detailed explanation of execution world, you can check out the video I've added as a card. Okay, in this step, I dynamically inject two files into each targeted website. First, I inject the file injection-types.js, which I've defined previously to add functionality for injecting JavaScript and CSS. This is not mandatory for use. You can choose to utilize it based on your preference. Now I include the specific content script for the website. This file contains custom JavaScript and CSS logic, and it's located in the inject-to folder. The file name is based on the hostname of the target website. So this is the essence of my injection process logic. Sorry, I forgot to add an add listener right here. Also, it should be state, not status. Alright, I think everything looks good. Let's reload the extension and start testing. The extension is enabled. Let's check example.com. That's perfect. This is the customized version of example.com that I defined. Now let's disable the extension. Very well. The extension works perfectly as it should. The extension is ready to use. In this step, I will provide some examples of how to use it on various websites. Additionally, I will demonstrate how to inject JavaScript and CSS into a new website. For each website you wish to inject, you should include its URL in the hostname format in the inject-to array. Additionally, you should add a JavaScript file named in the hostname format with a .js extension to the inject-to folder. This is my custom script for example.com. I have combined JavaScript and CSS to perform various tasks, such as DOM manipulation, fetch request, and style or color changes. For example, let me add Font Awesome library here and display some icons from that library. Okay, now let's execute a fetch request to retrieve my IP address from a third-party source and then display it in the console. This is the third-party JSON API I use to retrieve my IP address. Alright, here is an example of chart.js. Chart.js is a JavaScript library used to create interactive and visually appealing charts and graphs on web pages. Let's inspect what's happening in the DOM. You can view all the injections of custom JavaScript and CSS right here, before the HTML tag closes. Alright, now let's examine my custom injections on other websites. I'd want to demonstrate how my extension works on different websites, both with the extension enabled and disabled. It's Linktree website. It's X or Twitter website. It's ChatGPT website. It's Electronic Arts website. It's Facebook website. It's Wikipedia website. As I mentioned earlier, using the injector global object and its functions are optional. You can choose to use it if you are interested, or you can define your own logic. I'll show you some alert examples. Okay, it's my localhost website. And it's my modem router website. Alright, we have tested my custom scripts on multiple websites. Now let me show you how you can inject your scripts into new websites. You can inject your custom JavaScript and CSS code into any website in just 3 simple steps. Step 1. Add your websites where you want to inject your custom code inside the inject-to array. Step 2. Reload the extension. Step 3. For each website you want to inject, create a JavaScript file in the inject-to folder with the hostname format and a .js extension. Let's perform a real test on the YouTube website. Here are the custom scripts for each website that I demonstrated to you. Okay, first I add the YouTube website's URL in hostname format to the inject-to array. Then I reload the extension. And I create a custom script for YouTube from one of the existing scripts. Let's check the YouTube website. That's great. Now, when making changes, keep in mind that there is no cache for your custom scripts. You don't need to reload the extension when you are editing your custom scripts. You only need to reload the extension when adding new target websites to the inject-to array. Alright, we've learned how to inject unlimited JavaScript and CSS into any website. In this step, I will run the injector plus extension on Microsoft Edge and Brave browsers. My extension is compatible with all Chromium-based browsers. I've tested it on Google Chrome, Microsoft Edge, Brave, and Opera. In most Chromium-based browsers, you need to go to the extension settings, turn on developer mode, and then load your extension. Very well. This is Microsoft Edge. Now let's test it on Brave browser. That's great. We've successfully run the extension in 3 different browsers. In the final step of this video, I will demonstrate how to set a keyboard shortcut for the extension. This method also works on most Chromium-based browsers. To set a keyboard shortcut, open the Manage Extensions option. Then navigate to the Keyboard Shortcuts tab, where you can define a shortcut. For example, I've set Alt+I. Now let's test it. As you can see, pressing Alt+I toggles my extension state between enabled and disabled. In other words, it acts as an on-click event. Congratulations! You have successfully created a complete Chrome extension from scratch. Now you can use and further develop it. If you enjoyed this video, please give it a like, subscribe to my channel, and turn on notifications. I'd also love to hear your thoughts in the comments below. Thanks for watching. I hope it helps.
Because I will not quit, not because I want this. Don't try to stop me.